Okay, today we're going to be looking at section 6.6, which deals with systems of linear inequalities. Hopefully by the end of this brief section, you can say I can solve a system of linear inequalities by graphing, and I can solve real-world situations using systems of inequalities. So, our first thing we got to do is we got to talk about what does it mean to be a solution of a system of inequalities. So the same thing it would mean to be a solution of anything else. It means it makes the statements true. So if I plug it back into this one here, this 2, 8, I'd have y is greater than 2 times a 2 plus a 4. So that would be 8 is greater than 4 plus 4. Is 8 greater than 8? And the answer would be no. So I don't have to put it back into the other one. We know right away that this is not a solution because in order to be a solution, it would have to be true for both cases. Okay, in the second one, if I plug it back in, this would say a negative 2 is greater than a 2 times a negative 5 plus 4. So is negative 2 greater than a negative 10 plus a 4, which would be a negative 6? Is negative 2 greater than negative 6? Yes. So then I have to plug it into the second one, see if it works there. So I'd have a negative 3 times negative 5 plus 4 times a negative 2. Is that greater than 8? So I'd have a 15 plus a negative 8. So I'd get a 7. Is 7 greater than the 8? And that would be no. So this is not a solution either. So if it were to work for both equations, or inequalities, excuse me, then it would be a solution of the system, but since it doesn't, it is not a solution of the system. Okay, so how would I find a solutions on this system? I would simply have to graph both of these, and then we're going to find the overlap. So the first one, to graph this one, I'd have to minus off the 3x. So I'd have y is less than or equal to a negative 3x plus 1 or a 1 minus 3x. And if I went to graph that one, I'd have a y-intercept of 1, slope of a negative 3. So I'm going to go down 3 over 1, down 3 over 1. And then this would be a solid line, since we got an equal to with it. And then, graphing-wise, I'm not sure if you caught on yesterday, but if I have it solved for y and it says less than, I would be shading below. So I'm going to be shading below this line here. Okay? Now I come back to the second inequality. So for this one, I'd have to add an x. So I'd have y is greater than or equal to a negative 3 plus an x. So my y-intercept is a negative 3. I have a slope of 1, so I go up 1 over 1. And I'd have this line. And once again, it's going to be solid, since there's an equal to with it. And for this one, I would be shading above, since it says greater than. So where are the solutions at? The solutions are in this area over here, where both lines were shaded. It was true for both of them. So any point in that area would be a solution of this system. Okay, next one. So I'll give you some time to think about how you'd go about graphing this one. Okay, so we'd start at a 4. We'd go up 2 over 1. And we'd have this line. And this is again going to be a solid line. Okay, and since it says greater than, I'd be shading above. And sometimes I'll just do this, and I'll point an arrow so that I don't get so much scribbling going on. So I point an arrow, it's going to be shaded above that. And then for my second one, I'm just going to use a little different technique here. Maybe find your x-intercept. So you cover up your y's, and you'd get an x-intercept of a negative 2. The y-intercept, cover up the y's, or excuse me, the x's, then you'd get a y-intercept of a positive 2. So I'd have this and this. It's going to be a dashed line. Okay, and then to decide where I'm going to shade on that one, you could put in a 0, 0. So if I put in 0, 0, Negative 2 times the 0 plus 2 times the 0, is that less than 4? Well, 0 is less than 4, so yes, I'm going to be shading on the side of 0, 0. So I'm just going to extend this line a little bit further here. So I'm going to be shading on the side of 0, 0 on the red line. So I'm going to be shading below this one, above the blue one. So my area where they'd both be shaded is this little sliver in here. Okay? So now the final thing we have to do, we have to look at how we can use inequalities or a system of inequalities to do some graphing. Okay, so here's the deal. A young woman wants to make at least $200 a week and can work no more than 30 hours. She works at the library for $8 a week and babysits for $6 an hour. Or excuse me, library for $8 an hour. What is the system of inequalities that shows the possible combinations? So for this, we have to first think about, okay, what's the x, what's the y? So the two things we don't know are the number of hours at the library and the number of hours at the babysitting. Okay, so what would be my equations? Well, the first one, I want to make at least $200 a week. So how much money am I going to make? Well, the library pays $8 an hour times the number of hours, which is X. This would give you the amount of money that she makes at the library. The amount of money that she makes babysitting would be 6 times the number of hours that she works. So this combined would be your total amount of money. And we want to make at least, so greater than or equal to, $200. Okay? The second one, we know that she can work no more than 30 hours a week. So that would be like this. Number of hours at the library plus the hours at the babysitting has to be less than or equal to 30. Okay, so now we have to think about how we're going to graph each of those. So if I were to graph those, the thing that I'd want to think about is what's going to be on the bottom, what would be the bottom, what would be the side, and then how can I graph it? Okay, so down here, the X was standing for the hours at the, I can just put hours at the library, hours, library. So this would be hours babysitting. I'm going to back that up a little bit. Okay. So then, if I solve each of these for y, so if I solve the top one, I got 8x plus 6y equals 200. So if I minus off the 200, I'd have 6y is greater than or equal to 200 minus 8x. If I divide by my 6, I'd have y is greater than or equal to 200 divided by 6. It doesn't come out the neatest, but we'll figure it out here. Let me grab a calculator. 200 divided by 6 is 33 and a third. So 33 and a third minus 4 thirds x. Okay. So that's the first one. The second one, if I solve for y, it would simply be this. Y is less than or equal to a 30 minus an x, or minus 1x. So I need a y-intercept of 30, and I can tell you this. I can do hours, so I'm going to go by fives. Let's do 5, 10, 15, 20, 25, 30, 35, 40. Okay, then along here it's the same thing. 5, 10, 15, 20, 25, 30, 35, 40. Okay, my first one. I know that I'm going to be working 33 and a third, so that's like pretty close to here. Okay, and then my slope is a negative 4/3, so I need to go down 4. So that's down 1, 2, 3, 4 over 3. 1, 2, 3. Okay, so I've got a line that looks like so, something like that. Okay, and then I want to shade above that line. So I'm just going to put a little arrow above. Okay, and then the second one, I've got a y-intercept of 30. So I use red for this one, 30. And then it's negative 1. So I'm going to go down 1 over 1. So I'd have this line right here. And then I got a shade below that line. So if I continue this line out, okay, below this line now. So where am I going to be shading? I'm going to be in this small little region down here. So one of the questions is why do you exclude the points to the left of the y-axis and below the x-axis? Well, that's because we can't work a negative amount of hours. Okay, so what are some possible combinations? So that would look like this. X, Y. This is hours as a library and a babysitter. Okay, so what are some possible combinations? Well, I could work 25 hours at the library, and I could work 5 hours as a babysitter. I could work uh, 25 hours at the library and no hours as a babysitter. Okay, I could also work 30 hours at the library, or I could work 20 hours at the library and 10 hours babysitting. Okay, so those are some possible combinations. Okay, hopefully this makes sense. Again, if it doesn't, remember to come with some questions tomorrow, and we'll gladly get things straightened away. Okay, that is a wrap.